Hi, hi everyone. My name is Wenjam Abubakar Pedraogo. I'm a network engineer. I have been in this field for more than 10 years now, and today we're going to learn about static routing. I'm going to draw a diagram and we will implement that on packet tracer. So static routing is a way to give information manually on each devices on how to reach the next hop. So I'm gonna practice it, and starting routing is actually important and necessary when it comes to small network, I would say, where you have couple of routers or switches and you may think of using static route, but static route is not that much easy because you need to manually configure things. So it means that when you have two routers, they need to each know how to reach each other on both sides, not just one side. So it requires some efforts. As much as your network is growing, you might think of implementing a dynamic routing, which can be RIP, ERGP, OSPF, ISIS, or BGP. With that said, let's begin. So I have a PC here. This one I can call it server. And this one PC. So I will give a name to each device. Let's say this is Atlanta. And please, this is Dallas. And this is Eddie. And this is the server. So in each of them, we will have different types of network. So I'm going to say that this PC will be 192.168.1.2, and this server will be 10.10.10.254. Okay, here I will have 10.10.10.1. So it means that here I will have 192.168.1.1. So in between Atlanta and St. Louis, I will have another type of network. So I will put it 172.60.1.0 slash 24. Here I may have a 192.1. I can have 10.1.1.0 slash 24. And then here I will have 192.168.255.0 slash 24. So I want this PC to be able to ping this. You may see that where all works. I am assuming that NetMask is not that much important. Okay, so let's begin. Okay, we'll do the same thing on Cisco, and I will make a mix of routers and switches, layer 3 switches, so you will see a huge difference. Okay. Atlanta, St. Louis, Dallas, LA. So I'm putting the IP address on the gig 00, which is connected to St. Louis. So it's gonna be 172.16.1.1. The one connected to the PC. Then I'm going to that PC and I will put so here I'm good. Now I'm going to St. Louis. So now I'm configuring then sent list. So I have IP address 10.1.1.1, and I save. Now so now we're configuring early. So early is fine. So on the server, its IP will be 10.254. Then now in Dallas, it looks like one of the interfaces are not up. So everything is up. So from PC, I should be able to ping the gateway. PC can ping Atlanta. Atlanta should be able to ping Missouri. Okay. So Missouri can ping So send please can ping Dallas. So I'm gonna try to find that. So show IPN brief exclude unassigned. So I have 10.1.1.1 is there. So Dallas is presenting 10.1.1.2. And I do show run. CDP neighbor is telling me that it is connected to the gig 01 of Sandwich. So IPs has been swapped. Gig 01, gig 01. Gig 01 is already 10.1.1. So and then here it is gig 00. So in Dallas, I need to swap the IPs. So it's gonna be giving me an error because I cannot it's gonna tell me that I'm overlapping. Okay, so if I go straight and I do this is gig 01, you see, so I need to do default. Okay, so I set them to default. Okay, dot two. Now we can ping St. Louis, Dallas. Then Dallas should be able to ping LA. There is an issue, so it should be the IP where is wrong. So it should be the dot one here. So you can ping Dallas, LA, and from LA we will ping now the server. Okay, so we can ping the server now. From PC, our goal is to be able to ping now this server. Okay, so it's not working, and that's normal. So we need to do a static routing. Okay, so we have to do them one by one. So Atlanta need to read static routes here. So now we need to have a two-way communication in between Atlanta and St. Louis. What I mean by that is that Atlanta should be able to ping this network, which is in between. That means Dallas. So Atlanta should first be able to ping Dallas. Let's say to reach Dallas. So we need to do conf-day IP route. So the network for Dallas is a 10.1.10. Okay, can come here and do. So we need to reach this network. Okay, so IP route. So .0. So we'll send that to our next port, which is St. Louis, but the port facing Atlanta, which is the 172.16.1.2. So 172.16.1.2. So at this point, should I be able to ping? So I will do ping 10.1.1.2. I can ping. Why? Okay, let me do a trace route 10.1.1.2 and see. So you see that it is really sending the packet to the 172.16.1.2, but it's still not reaching. Why? In fact, the ping is working, but now Dallas doesn't know where to send back the response. So we need to configure a static route also on Dallas side. All right. So we go on Dallas, and Dallas should know how to reach that network. Now it is working. Now, can the PC reach Dallas? If you said no, you're right, because the PC is in another network. So as long as the PC can't even reach St. Louis, let's see again. So we need also to add a rod that will allow St. Louis to reach the PC and vice versa. So let's go here. This one, okay, dot two, which is St. Louis, we can't reach. So we also need to add a static rod so the PC can reach St. Louis, because the PC can't reach Dallas if it can't reach St. Louis. That's how static routing is working. So conft dot zero. Now we can reach it. So at the same time, can the PC ping now Dallas, the 10.1.1.2? Let's start with the 10.1.1.1, which is the interface of St. Louis facing Dallas. So why? Because the ping is going, but Dallas doesn't know how to reach that network. So we need to go in Dallas and add again another static rod. Then it's gonna send the now it is working. Now next step is LA. Now for the static routing to work again, so Dallas should be able to reach the server which is behind LA. Okay, and the server should be able to reach Dallas, then St. Louis, then Atlanta. Okay, so let's begin. So IP route 10.10.10.0 So this is 192.168.255.2. So it's gonna send that to Ellie. So now Dallas can reach the server, okay? And the server has to know where to reach conf. So now Dallas can reach the server. Now we want the PC to be able to reach the server. So now the PC can reach Dallas. So we want the PC to be able to reach Atlanta. Atlanta to reach Ellie. And so on. So Dallas can reach the server. So St. Louis should be able to reach the server. Okay. So let's go on St. Louis. So St. Louis wants to reach the server Ellie first. Ellie, which is the 192.168.255. So now we have St. Louis able to ping Ellie. Now we want St. Louis to be able to ping the server. So conf. So it's gonna send that to the entry on Ellie, which is a 192. So from Ellie, now 10.10.1, it is working. Now the server, it is working. Now we want the same between LA and Atlanta. We want Atlanta to be able to reach LA. okay? And we also want Ellie to be able to reach Atlanta. So let's begin. So, so what do we have here? Okay, so we'll do IP route 9.168.255.0.0, and this would go to 10.1.1.1. So now we can reach Ellie. Now we want to reach the server. Okay, so Ellie need to know the 172 network. So it's gonna take it from St. Louis, and St. Louis will be so now Atlanta can reach that IP. Now Atlanta is attempting now to reach the 10-10-10 network. Okay. Now we can ping the 10-10-10 one, but now we shouldn't be able to ping the server. We need to have, okay, we have both. So that is done. Now, can the PC now ping the server? Okay, ping.1.2. Yes, ping the server. No. So the PC is in 192.168.1.0. So we need to add that on Ellie. Now the PC can reach Ellie on the second interface. Now the PC can reach simply here. So if we enable HTTP on HTTP is on. So if we go here, we can do So this is all about static routing. I hope you enjoy, and please comment below and subscribe and like. Thank you guys.